everyone. This video is about the cylinders, particularly those we are using in the anesthesia machine or in the operation theaters. The last video I made was on central pipeline systems, which was about the manifold, the pipeline, and ultimately the pipeline gases getting delivered to the machine. But there's another way we can deliver gases to the machine, which is not pipeline, which is cylinders. Now in the anesthesia machine setup, we have three types of pressure systems: high pressure, intermediate pressure, and low pressure system. The cylinders, though, are considered a part of high pressure system. There are some of the people, they consider cylinder as a separate entity and not a part of anesthesia machine as such. So that remains a controversy. So if someone says cylinder is a part of high pressure system, you may say yes. If they say cylinder is not a part of high pressure system, then again that may be a correct statement as well. Usually it is not a part of the high pressure system though. The high pressure system consists of the cylinders. These are the nitrous oxide and the oxygen cylinders. Then they are connected to the anesthesia machine via a hanger yoke assembly. Then there is a check valve. Check valve prevents the back pressure of the gases, because gases has to move from the cylinder to the anesthesia machine. So this check valve will prevent the backflow. After the check valve, there is a cylinder pressure gauge. This will tell you what is the pressure the cylinder has. And because it has a lot of pressure, it has to be regulated or down regulated basically to reduce its pressure to somewhat near to the pipeline pressure, a bit lower than the pipeline pressure to be precise. Cylinder, the parts of the cylinder is, it has a body, shoulder, valve, and a neck. It has seamless body. If we talk about the history of cylinders, it was earlier made by a hand forged steel, which was heavy, thick wall. It had less tensile strength, and the volume which could be kept inside was very low. So it needed some modification to improve its tensile strength, to decrease its weight, and to put more gas into it, precisely 20% more gas inside it. So the hand forged steel was converted to molybdenum steel. In the MRI setup, however, we cannot use molybdenum steel because that is magnetic. So it can go and damage the MRI machine. It can cause fire hazards or a blast particularly. So they are aluminium cylinders for the MRI suits. After the material of the cylinders, we come on to the markings which are present on the cylinder. The cylinder has a front side and a back side. The front side is characterized by this. You can see this is the Bodock seal, and then these are the holes on the cylinder. The pins are present on the machines, holes are present in the cylinder. So on this front side, if you can see, there is a marking called DOT, D-O-T. This is known as Department of Transport Specifications. Then after DOT, there is a number called 3AA. This 3AA is known as steel. So the material of the cylinder is steel, then they'll write 3AA. And then it is 2015, it is written. This 2015 is nothing but the service pressure. Service pressure is defined as the pressure at which air is filled into the cylinder. Alright, so this is the marking present on the front of the cylinder. Then we have some very random markings like serial number, ownership mark, manufacturer mark, not very important. On the back side, we can see the markings. There is a hydrostatic test marking. Hydrostatic test is a type of test which tells you the quality or the rigidness or the quality basically of the cylinder. So under the cylinder has to go undergo certain test, one of them being a hydrostatic test to test its quality. Then we have again this chromium molybdenum steel marking, then spin process, and the elastic expansion is mentioned. Elastic expansion is what happens is you fill the cylinder with 1.6 times of the service pressure, and then when it is filled to such a pressure, the cylinder is going to expand. If this expansion is more than 17.5, then it is considered comparatively that the cylinder is not as good quality as it should be, and this is then checked every 5 to 10 years. Then these are the dates which are mentioned on it, and the retest past specifications, inspector's mark, right? These are certain markings, the most important being the type of cylinder, the material of this cylinder, the service pressure, the expansion, elastic expansion. In certain cylinders, a date was marked on this plastic disc. If you can see this plastic disc, that plastic disc had a date marked on what was the last cylinder date, last testing date for the cylinder. It is usually not present in the modern cylinders though. As we just read that cylinders have marked 3AA, they are manufactured by steel. If it is written 3AL or 3ALM, that indicates it is made up of aluminium. Markings engraved on the cylinders, we have already read: service pressure, dates of the test, chemical formula of the cylinder content, which is oxygen or nitrous oxide, whatever that is. And a tare weight is also mentioned. Tare weight is the weight of the empty cylinder. Then we come on to the sizes of the cylinder. They are named like B, D, E, F, G, H, M, and they have different capacity, different pressures, different tare weight. That is different weight when they are empty. In the anesthesia machine, we usually use E type of cylinders. And one thing you should remember that BDE, these three cylinders, they have a valve which is known as pin index. Similar to the pipeline systems where there we have diameter index safety system, in this cylinder, when they are connected to the anesthesia machine, they have a safety mechanism called pin index safety system, so that a wrong cylinder is not getting connected to the machine. In the larger cylinders though, the valve type is not pin index, it is bull nose type. This nomenclature for the cylinder, that is BDEF, these are the American type of nomenclature. In Indian cylinders, we have different nomenclature, which may vary from institute to institute. Then we come on to the color coding. Oxygen is black body with white shoulder. Nitrous oxide is blue. Carbon dioxide is gray. Cyclopropane orange. Helium is brown. Antonox is blue and white combined strips. Then in the color coding itself, there's a new international color coding which was started in 2010. It is very similar to the color coding that we just read, which was given in 1949, but now it has, the cylinder body is usually painted very normally, but the neck, it has these combinations you can see downwards, not very important for from Indian perspective. Then we come on to the cylinder valves. They are made up of the material, they are made up of brass and chromium. The parts are, they have a stem which is usually opened when it is rotated anti-clockwise. In the behind and in the front side, there are differences. At the behind part of the cylinder, it has a conical depression, which will receive the retaining screw of the yoke. So because you have to fit the cylinder into the machine, so when the cylinder is put into the hanger yoke assembly, the conical depression will get the retaining screw of the yoke, and below this, below the conical depression, this is pressure relief device, which is again a safety mechanism, that if the pressure of the cylinder increases to certain extent, this pressure relief valve will release the pressure, similar to a APL valve. On the front side, we have a port and we have the pin index system. This same diagram, which consists of the back and front, if you look at the cylinder from the side view, so this will be the back side and this is going to be the front side. On the back side, you can see there was this conical depression and there was this safety relief device, which was the pressure relief device, and this is the cylinder which contained the gas. If you rotate the stem, this spindle, this will move up and this screw is going to move upward. The gas will go from here and will come out from this side. This exit of the gas is the outlet port, and then these are the holes for the pin index system just below the outlet port. These holes will correspond to the pins on the anesthesia machine. That is how a correct cylinder will be placed into the machine. This was the structure for the cylinder valve. Then we come on to the pin index safety system. You already know now that the pins, they are present on the machine and the holes are present on the cylinder, the front side of the cylinder. Now these holes, they have, if you make a circle out of the hole, so the radius of curvature for that circle will be 9 by 16th inch, or which is approximately 14.3 mm. And the pins on the yoke, they have a diameter of 4 mm and the length of 6 mm. The diameter is 4.75 mm. The most important value being the 9 by 16 inch and the pin's diameter and length. This is again the representation of the hanger yoke assembly. You can see the cylinder is going inside is this hollow cavity. On one side it has the retaining screw which will fix to the conical depression that we saw just now, and on the front side of the cylinder, if you see, this is the front side, this is the rear side. On the front side we have this hole, and this hole has a washer and a nipple. We'll see what is a washer and a nipple, but you can see that just this is the outlet port, and then we have the holes, and these holes will correspond to this pins on the cylinder on the machine. As we just read that there's a pressure relief device just below the conical depression. This is not the only mechanism which was present in cylinders earlier. This fourth number, we can see this is a pressure relief device, or the spring loaded valve, which lets the pressure reduce after a certain pressure has built up in the cylinder. But earlier we had rupture disc, fusible plug, and obviously a combination of these two. They were again a mechanism for safety. Now let's talk about what was a rupture disc, which was made up of copper, and what was a fusible plug. In the fusible plug, you can see it was made up of an alloy which was known as Wood's alloy. This Wood's alloy was made up of cadmium, bismuth, lead, tin. You have to remember these material. So this wood alloy, it has a property that it melts at 150 to 170 degree Fahrenheit. Alright, so if the temperature, again a safety mechanism, if the temperature of the cylinder increases to this level, it will melt down. This alloy will melt down and the gas will leak out. So that will prevent the cylinder pressure to build up drastically and leading to the dangerous scenario of the burst of cylinder. The problem with the Wood's alloy was that it can only be based on the temperature, not on the pressure, and it cannot be reused. So if once the wood's alloy has melted, it has to be sent to the company to make a new plug. Apart from this fusible plug, one mechanism in the modern cylinders, which was the pressure relief device, which is spring loaded valve, this we have already read, that is just releasing the pressure if it builds. But the rupture disc, or also known as the frangible disc, it has a bursting pressure. That means minimum pressure required to burst the disc. So if the pressure increases, it won't let the air move out, it will simply rupture. And because it will rupture and the gas will move out, it will prevent this pressure to build to an extent that it may burst. Again, it has to be sent to the company, because once it has broken, it cannot be replaced then and there. In the Indian cylinders, the pressure relief valve or the fuse is not here. It is present in between the cylinder valve and the cylinder body, and it melts at high temperature to release the gas outside. So these are certainly some of the differences from the Indian and the American cylinder. We come on to the term cracking the cylinder. Cracking is before connecting to the yoke of the machine, the cylinder valve needs to be cracked. That means it has to be opened slightly. Why not suddenly? We'll see the reason. It is opened only slightly to blow away any dust or flammable silting on the valve. And the person opening the cylinder should be positioned so that the valve outlet opens away from the self, patient, and the machine. Then this is how you open the cylinder. Yeah, this you must have already done in your OTs. So what was the need of cracking a cylinder is because sudden opening of cylinder, if you suddenly open, if you do not do it slowly, this sudden opening what will happen is, this is the yoke assembly, this is the pressure regulator. So if you open it slowly, the pressure regulator can regulate the pressure, but if you open it suddenly, the pressure regulator cannot change the pressure. So suddenly what will happen, that will lead to increase in the temperature in between the yoke assembly and the pressure regulator, and it cannot dissipate into the environment. So that sudden production of so much of heat is known as the adiabatic process there, and which will lead to explosion if suppose some dust particle is present in there. So that is the reason we crack a cylinder, that is slowly open the cylinder. After the cracking, we have the test for the tensile strength. The cylinders, they have to undergo test to ensure their safety. So every 10 years for steel cylinders and every 5 years for composite cylinders. A specific shape and color coded plastic ring around the cylinder neck indicates the time of next testing. That we have already read, that a red colored marking around the cylinder neck, it has dates written on it. This is the diagram for hydraulic test, where you can see that water is filled and the cylinder is put inside, and then the cylinder is filled with the pressure 1.6 times of the service pressure. So if the cylinder expands more than 7.5 cc, then the test is failed. That means the cylinder quality is not good. Again, apart from the hydraulic test, we can do a flattening test, impact test, or band test, just to check the quality of cylinder. Next, we come on to the filling of the cylinders. Remember, oxygen is a gas, and nitrous, which is filled in the cylinder, is a liquid. So it has the principles of both the gases, oxygen or the nitrous, is different. In the filling of cylinders, oxygen is filled up to the service pressure, which is 1900 to 2000 psi. Because it is a gas, because why is it a gas? Because the critical temperature of the oxygen is minus 118.6 degree. For nitrous, it is 750 psig, because its critical pressure is plus 36.5 degree. That means at room temperature it is liquid actually. So we cannot fill the nitrous cylinder completely with liquid, because then the gas will not have space to expand. So you have to define certain density, filling density for nitrous cylinder, which is usually 68%. Now if we check the filling densities, is weight of nitrous by weight of water. By this calculation, uh, water has a density of 1, therefore the mass is equal to volume of cylinder is usually what we fit in the anesthesia machine is 5 liters, so it will be 5 kg weight. If we substitute this value of weight of water with 5 kg, which is the E type cylinder, so we can know the weight of nitrous which is filled, which is 3.4 kgs. Now the tare weight, or the weight of the empty cylinder, is 5.4 kg for a E type cylinder. So you can see that the total weight of a completely filled nitrous cylinder with a filling density of 0.68 has a weight of 8.8 kgs. This is how you have to check the how much nitrous is left. So basically you have to weigh a nitrous cylinder to know how much liquid nitrous is remaining into the cylinder. Next we come on to the safety features. As we know that they are made up of molybdenum steel now, so they have high tensile strength. They are color coded. They have a seamless body, so that means the joints present in the cylinder have reduced, the chance of leakage reduces. Then they have safety relief valve and a pin index safety system. In the hanger yoke assembly, you can see this is the machine part. On the machine side we have a nipple, and around this there's a seal known as Bodock seal, and it has pins. So the machine has this assembly. You have to remember the name for them. That is nipple with a Bodock seal. These are the functions of yoke assembly. Not very important. Yoke assembly that you already know now. The gate is known as actually the swivel gate. Bodock seal, Bodock seal, it is made up of the neoprene rubber, and this is the neoprene rubber, and around this you can see there's the aluminium ring. This is the aluminium ring, and because you know that the cylinder is going to be fitting by the holes and pins, so if you use more than one of these seal, it can actually bypass the pin index safety system. So the pin index safety system will fail if you use more than one Bodock seal. This diagram is again showing you the same structure. There is a retaining screw. This is the pressure gauge. This is the valve seat, the cylinder valve stem, and this is a unidirectional check valve. Now if it is the cylinder is not connected to the machine, so that time you have to close it using a yoke plug. So that's all for cylinders.